Welcome back. In the previous video, we implemented a crosshair spread factor that is dependent on our velocity. And the higher the velocity, the more the crosshairs spread. Now in this video, we're going to add a little bit more to this crosshair spread multiplier because we want to base this not only on velocity, but on other factors such as whether or not we're in the air. So as soon as we jump, I'd like this to cause the crosshairs to spread a little bit more. And as soon as we land, we want the crosshairs to quickly shrink back. Now we don't want it to just jump back to the shrinked position. We want it to smoothly shrink back. So we're going to be interpolating. So let's get started. Now here in the header file, you'll see that we created this crosshair in air factor. So if we go back to the function we created called calculate crosshair spread, you'll see that our crosshair spread multiplier is affected by our crosshair velocity factor, but we also want it to be affected by our other variables such as crosshair in air factor. So let's add the crosshair in air factor to this as well. Now I could tell this is going to be a long line, so I'm going to go ahead and put each of these on their own line here. So that way this is looking nice and tidy. Now the crosshair in air factor is going to be different based on whether or not our character is in the air. So when we calculate it, we're going to have an if check to see if the character is in the air or not. And we can do that from shooter character by calling get character movement to get the movement component, and from the movement component we can call is falling, which is how we can tell if we're in the air or not. So we're going to have a case for if this is true, and we're going to have an else case for when it's not true. Now we're going to have to comment these so we can understand what it is we're doing. For this, we're going to calculate crosshair in air factor. And then of course up here we're calculating the crosshair velocity factor. And I'll go ahead and just place a comment here that says is in air. We're checking to see if the character is in the air. Now if the character is in the air, then our crosshair in air factor will be different than if it's not in the air. So we're going to say crosshair in air factor, and we're going to set this based on the result of an interpolation. So we're going to interpolate using fmath finterp2, which takes a current value, that's going to be our crosshair in air factor, and then we're going to have a target value. Now this depends on how much we want crosshair in air factor to affect the overall spread. While we're in the air, we're going to want our crosshair in air factor to be interpolating toward a certain value, and this can be tweaked and it can be parameterized, but I'm going to go ahead and give it a value of 2.25 for now. We'll see how it looks and we can change it later if we need to. Next, finterp2 takes delta time, so we're going to give it delta time. And then it takes an interp speed. Now if we're in the air, if we just jumped, I want this interpolation to be fairly slow. So the crosshairs are going to be spreading outward very slowly as we're in the air. So I'm going to give it a small value like say 2.25f. And since this line is running off the screen, I'll go ahead and put these all on their own separate lines. And for the comment here, I'm going to say spread the crosshairs slowly while in air. And if we're not falling, in other words, if we're on the ground, or if we just hit the ground, then this if statement will fail the if check and hit the else statement. So let's go ahead and paste here this calculation of crosshair in air factor. And I'm going to stick a little comment here and say character is on the ground. And crosshair in air factor is now going to be interpolating to 0. And doing so very quickly, because as soon as we hit the ground, we want those crosshairs to shrink back right away. And we don't want crosshair in air factor to have much influence on it. So finterp2 has the second parameter as the target, and we're going to set that to 0.f. And its last argument is the interp speed, and we want this to be high because we want it to shrink very quickly. So I'm going to set it to about 30.f. And again, we can tweak these parameters, but we're going to see how this works for now. Let's give this a comment and say shrink the crosshairs rapidly while on the ground. So basically, we're interpolating every frame the crosshair in air factor. If we're falling, then we're going to interpolate this toward a value of 2.25. And if we're on the ground, we're interpolating it very quickly to a value of 0. So the crosshair spread multiplier overall is going to be affected by this. If we're in the air and we've been in the air for quite some time, maybe a second or two, then this crosshair in air factor will have been interpolating toward 2.5, so it'll be approaching 2.5. And so crosshair in air factor will be contributing a lot more to the crosshair spread multiplier. Let's go ahead and compile this and see how it works. Okay, back in the editor, let's press play. And we're moving, the velocity is affecting it. That's nothing new. But now when we jump, now it spreads, and notice that as we're in the air, it spreads out very slowly, and then when we hit the ground, it spreads back in very quickly. So spreading slowly while we're in the air, and very quickly when we hit the ground. But it's still a smooth transition. We're still just interpolating. And both the velocity and the fact that we're in the air both affect the crosshairs independently. They both have their own component to the crosshair spread multiplier. So notice, if we're just sitting still, we have this baseline spread amount, and we jump and it spreads and then comes back to the normal. But if we're running, we have a different baseline spread amount once we're at the maximum run speed. And if we jump, then it spreads even more, but it shrinks back down to that maximum for the run speed. And so there could be any combination of those two at any given point in time. So that's going to go ahead and conclude this video. In this video, we went ahead and added to the crosshair spread multiplier the crosshair in air factor. And we used an if check to see if the character is falling, basically if we're in the air. And if so, we take our crosshair in air factor and set it equal to the result of an interpolation to the value of 2.25. And we're interpolating toward that value very slowly with an interp speed of 2.25. We can tweak these, remember. But if we're not in the air, if we're on the ground, then we're interpolating toward a value of 0 very quickly with an interp speed of 30. And crosshair in air factor is going to be very small. It's going to be getting very small, shrinking. And so its contribution to the crosshair spread multiplier will be quickly getting small, as indicated when we tested it out and saw that when we hit the ground, it shrank back down. Okay, so here's a challenge for you. I want you to implement the next crosshair factor, which we created and called crosshair aim factor. Now, what I want you to do is when we're aiming, I want the crosshairs to shrink in. And when we're not aiming, I want the crosshairs to come back out. Now, I don't want this to be a jerk. I want it to be very smooth and quick. I want it to quickly shrink in the crosshairs when we're aiming and spread the crosshairs back out when we're not aiming. Do this by implementing our crosshair aim factor. It's going to be very similar to what we did for the crosshair in air factor. There's going to be a little bit of a difference there, but I want you to go ahead and give it a try. In the next video, we're going to implement this. So if you can't get it, don't worry. Go on to the next video and we'll do it in the next video. We'll see you soon.